Hello everyone, today we'll talk about the problem pass the pillow. We have some people standing in a line and a pillow that starts with the first person. And in every step, a person passes pillow to the right. When it reaches the right end, then people start passing it to the left. We are given the number of people, we're given the number of steps. Of course now it again starts going to the right and so on. And we have to answer after a given number of steps at what position the pillow is. In this problem, it's possible to directly simulate this process and arrive at an answer. So remember, if you're going to the right, to the left, move in the appropriate direction. If you cannot move anymore, then flip the direction you're going in and go in the other and so on. However, it's not very interesting. There is another more interesting solution based on more mathematical approach. And it also has the benefit that it's faster. It's essentially constant time. So the first thing that we can use is there is this notion where the number of steps is much greater than the number of people, that our situation will repeat periodically. Because we start at a given person, so let's say person 1, and after we go through all the people once and then all the people on the way back, then we again are at person 1 and again we're going to the right. Which means that for those full cycles, we can forget them. So how can we take a big number and separate some notion of a full cycle and remove all the full cycles from this number? Well, this is where modulo comes into play. This is a remainder from division. That's because in this case we have 3 steps to the right, 3 steps to the left. That means that every 6 steps that we start with, we might as well have not done these 6 steps. So that means that the number of steps that were given should be the remainder from division by 6 of the original number of steps. So that's the first part. We use modulo to make the number of steps not exceed essentially twice the number of people. Twice the number of people minus 2 in this case. So that's the first approach, the first idea. And then we might just write a solution based on that. So we start by taking the remainder from division by 2 times the number of people minus 1. So the number of people minus 1 is the number of steps in each direction, and there are 2 directions, so we take it times 2. And in that case we can immediately calculate the result. Because if we're going to the right with the remaining steps, then it's simple to calculate the result. And if we're going to the left, then it's also simple if we look from the right end. So we're going to the right if the number of steps does not exceed n minus 1. Here I've written less than, but the solution would also work if this was less or equal. That's because for time equal to n minus 1, both of those formula give the same number. So if we're going to the right, we have to start at 1 and take the number of steps that were given, and that is the number of the person that ends up with the pillow. If we're going to the left, then we have to first do the n minus 1 steps to get to the right person. Now we start with the person number n, and every step that remains, so this is the person number n, and every step that remains reduces our number by 1. So this is a solution. But it's still unsatisfying, because we've managed to capture the idea of having some full cycles that end up at the beginning and only caring about the final separate part of a cycle that remains. We used modulo for that. But now we have this idea of going to some position and then bouncing off that position and going backwards. And how can we model that mathematically? Well, you might be familiar with the idea that when you have, for instance, the standard y equals x line, the absolute value function would look something like this, without this part. So essentially, this would be the absolute value of x. And notice that it has this bouncing off situation, which is similar to what we're looking for. Specifically in our case, what we want is the same thing but flipped, and also going up and then going down, starting at 1 and ending at n, and then ending at 1 again. But if we want this thing to be flipped upside down, then we just have to put a minus sign before our absolute value, because by negating we flip the whole diagram upside down. And also we have to add something to shift it up or down. So this will be absolute value, shift it up or down. To shift it left or right, we just have to write something within these parentheses. So we want the general form of absolute value to capture this bouncing off situation, and it turns out that we can do it. In fact, we start with the same modulo that we did before, so the same thing that's happening here happens here, and then the result is just n minus the absolute value of time plus 1 minus n. And the final thing that remains is how to come up with what to write within this absolute value. You might, of course, just go at it with trial and error and try to come up with what to write here yourself. Notice that the absolute value function is piecewise linear. It has two linear parts, so you don't need many positions to interpolate what the values should be. However, there is a more general way, because one way to define the absolute value is that it's simply x if x is, let's say, greater than equal 0, and minus x if x is less than 0. And notice that this equality sign could also be skipped above and added below, because minus 0 and 0 are the same thing. So this was foreshadowed here where I mentioned that we have here less than, but less or equal would also be correct. So this is the definition of the absolute value. And notice that here in our solution we have some if and else. So we can look at this if else, convert it so that it compares to 0, and then the thing that we compare into 0, we can take that if statement and compress it into a single absolute value, because this absolute value will have this if comparing with 0 built in. So here we compare time less than n minus 1. Simple transformation. Time minus n minus 1 taken together is less than 0. That's the same thing that we've written above. And now we can use the absolute value of time minus n minus 1 to get rid of that if. So the final step is, because here we have something less than 0. We know that if it's less than 0, we have to take it with a negative sign. Otherwise, we have to take it with a positive sign. So you have to start with minus this in this branch that's less than 0, and plus this in the other branch. And the only thing that remains now is to look at what we have above and make sure that the result is the same. So what should we write here when we start with minus, time minus and minus 1, all taken together? Well, to make sure that it's time plus 1, then we have to get rid of that n. So we take n minus this. And in the latter case, we have n minus this. Well, that's exactly the thing that we want. So it stays here. And of course, what we have now is n minus this whole part with this if, and we know that this is equal to the absolute value of the thing that we had in our if. And of course, this is a bit of a... I blindsided you maybe, because time plus 1 minus n is exactly the same thing as time plus n minus 1. So this is indeed the same thing that we've arrived at here.